As we know that lightning is one of the most natural and serious causes of overvoltage. So in this video I would like to explain briefly the lightning phenomena, the way it is caused and the manner it affects the power equipments, building frames, transmission lines and etc. It is matter of great surprise to know that over the whole world, more than 40,000 lightning strokes per day and less than 100 lightning strokes per second takes place. Transmission lines functions as arteries that carry electricity from power stations to regions where the power is needed. Therefore, it is vital to control the construction and maintenance costs of these lines because while the frequency of transmission lines falls resulting in power loss has decreased year by year, yet the trouble due to natural cause lightning is not reduced yet. Lightning is an electric discharge in the form of a spark or flash originating in a charged cloud. It has now been known for a long time that thunder clouds are charged, and that the negative charge center is located in the lower part of the cloud where the temperature is about minus 50 centigrade degrees, and that the main positive charge center is located several kilometers higher up, where the temperature is usually about minus 200 centigrade degrees. In the majority of storm clouds, there is also a localized positively charged region near the base of the cloud where the temperature is about 0 centigrade degrees. Under the influence of sufficiently strong fields, larger water drop becomes elongated in the direction of the field and become unstable, and streamers develop at their ends with the onset of the coronal discharge. The height field need only to be much localized, because a streamer starting from one drop may propagate itself from drop to drop under a much weaker field. When the electric field is the vicinity of the one of the negative charge centers builds up to the critical value, an ionized channel is formed, which propagates from the cloud to Earth with a velocity that might be as high as one-tenth of the speed of light. What appears as a single flash of lightning usually consists of a number of successive strokes, following the same track in space, at intervals of a few hundredths of a second. The average number of strokes in a multiple stroke is 4, but as many as 40 have been reported. In discharging of the lightning phenomena, there is mainly three paths of discharge. In the first discharge path, which is from the leader core of the lightning stroke to the earth, the capacitance between the leader and the earth is discharged promptly, and the capacitances from the leader head to the earth wire and the phase conductor are discharged ultimately by traveling wave action, so that a voltage is developed across the insulator string. The second discharge path is between the lightning head and the earth conductor. It discharges the capacitance between these two. The resulting traveling wave comes down to the tower and, acting through its effective impedance, raise the potential of the tower top to a point where the difference in a voltage across the insulator is sufficient to cause flashover from the tower back to the conductor. This is the so-called back flashover mode. The third mode of discharge is between the leader core and the phase conductor. This discharges the capacitance between these two and injects the main discharge current into the phase conductor, so developing a surge impedance voltage across the insulator string. At relatively low current, the insulation strength is exceeded and the discharge path is completed to the earth via the tower. This is the shielding fail of the direct stroke to the phase conductor. The protection of the structure and equipment from the last mode of discharge by the application of lightning conductors and earth wires is one of the oldest aspects of lightning investigation, and continues to do so. Lightning can produce overvoltage when it hits either the line conductors, which is direct strokes, or a point in the vicinity of the destruction network, indirect strokes. Overvoltage can be impressed upon a power system by atmospheric discharge, in which case they are called lightning overvoltages, or they can be generated within the system by the connection of or disconnection of circuit elements or the initiation of or interruption of faults. The latter type are classified as temporary overvoltages if they are of power or harmonic frequency and sustain it, or weakly damped, or a switching over voltages, if they are highly damped and of short duration. Because of their common origin, temporary overvoltages and switching surge occur together, and their combined effect is relevant to insulation design. The probability of coincidence of lightning and switching surge, on the other hand, is small, and can be neglected. The significance of temporary overvoltage in respect to insulation coordination lies in the requirement that surge diverters must be able to receive against sustained voltage or risk destruction. In this video, I hope that I managed to briefly explain the problem of lightning strikes nearby the transmission line. Thank you for watching.